Hello, this is lecture 7 already, which means we are entering the third week of the semester. Uh, we have been talking about the dominant equilibrium, dominant strategy. And the dominance means whatever strategy your opponent or other players choose, if you have one strategy of your own that always better than the other your strategies, that we call that dominant strategy. Okay, so formally, mathematically, let's define this dominant strategy. We are talking about dominant equilibrium. The definition of dominant equilibrium is equilibrium that composed of dominant strategy. So this is essential. This Greek letter would be read by mu1. Mu1 denotes the payoff of the first player. So I would use mu as the, this one over here. That is the payoff of the first player. What decides the first player's payoff? The strategy of first player and the strategy of second player. For example, if the first player in rock, scissors, paper game choose paper, the second player choose rock, the first player's payoff would be 1. If it's rock and paper, it would be -1 because first player loses. So the payoff would be decided by the strategies that each player chooses. Okay? So mu1 parenthesis s1 star s2 is when player 1 choose s1 star, player 2 choose s2, the payoff of player 1. Likewise, mu1 s1 0 s2 would be when the player 1 choose s1 0, player 2 choose s2, what would be the payoff of player 1? And this means the left side, if s1 star is the dominant strategy, right here, the payoff from the choosing dominant strategy is bigger than something else. S1 0 is not the dominant strategy. So you're comparing the payoff when you choose the dominant strategy, the payoff when you choose not the dominant strategy, then the payoff, of course, would be always bigger. Here it's strict inequality. It's not like bigger than or equal. It's always bigger when you choose dominant strategy. This is the definition. Okay. So here, another catch. We didn't say anything about S2, your opponent or the other player's strategy, which means whatever strategy the other player may make. Your dominant strategy gives you a bigger payoff than your not dominant strategy. Same definition for the second player. Okay? Looks complicated, but then when you kind of accustomed to it, this way of expressing, defining things is much clearer than the verbal definition. Verbal definition, it has always a blur, not so clear area that may confuse you ultimately, but when you're accustomed to this mathematical expression, definitely there's no confusion, no gray areas. Dominated strategy. Let's say S1 prime is dominated by S1 sharp. Okay. Oh, sorry. It should be reversed. S1 sharp is dominated by S1 prime because I put it here. So S1 prime dominates S1 sharp. Once again, this is wrong. You change S1 sharp here and S1 prime here. Okay, usual mistake. I make a lot of mistake. I apologize in advance. So when S2 was chosen, you have S1 that gives you, the player 1, the bigger payoff all the time compared to S1 sharp, then S1 prime dominates S1 sharp. Here, we say for some against for all, the dominant strategy should beat up everybody else. Dominated strategy if just one strategy S1 prime beat up S1 sharp, S1 sharp is already dominated. It doesn't have to worry about other things. If one person dominates you, that's it. The reason as I said, we are in the business of choosing the best strategy. I mean, who's the strongest guy in your class kind of thing when you're fighting each other. If you want to be dominant, you have to win over everybody else by one-to-one fighting. If you were beat up by another student, you're already done. You can never be the best. So that is the reason why we don't have to check all strategies like dominant. Here for some, just one is enough. Okay. Dominant equilibrium. As I said, dominant equilibrium is equilibrium composed of dominant strategies. The well-known example is prisoner's dilemma. Look at this typical. There's a suspect. The police has suspect 1 and suspect 2 who commit a crime together. If they deny, there's no evidence whatsoever, so they will be in jail for 1 month. If both of them confess, they have a good evidence, the police, so they would be guilty in many charges. So it's -10, -10. What police can do is he can persuade suspect 2 if you confess. While the suspect 1 is not confessing, then we will set you free immediately and make the sentence of suspect 1 -20 because you are a good guy and this suspect 1 is the main bad criminal guy, so we are willing to let you go kind of thing. So this persuasion in real world work very well, they say. So the confession would be the equilibrium. Like the fist fight and gun, fist fight and denier is like fist, confession is like gun. So because you remember that okay, let's go back. In this game, the equilibrium, dominant equilibrium was gun and gun. Okay, because whatever Bill does, for Tom, gun is always better than fist. Whatever Tom does for Bill, gun is always better than fist. So gun and gun is the dominant equilibrium. One thing you should notice here is they will get -20 and -20. But there's another possibility, -10 and -10. Compared to -20 and -20 payoff, -10 and -10 is much better. Okay? But they end up choosing -20, -20. We have a word for that. Let's go back to, okay, here, Pareto optimal. Pareto optimal means if both of people can increase their payoff, if that is possible, we can never say the current state is a optimal state. Like here, the Pareto is I think Italian economist, like 100 years ago or something. He invented it. So he invented this concept. For example, -10, -10. this cannot be a Pareto optimal. Why? Because there's a possible choice -1, -1. Each player, suspect 1, suspect 2, their payoff increased by 9. So most of them would rather have -1, -1 instead of -10, -10, but they ended up choosing this. So we cannot say it's desirable. Compared to what? Compared to -20 and 0. If you move -10, -10 to -20 and 0, the second suspect improved by 10. The first suspect decreased by 10. So, the second suspect would be happy, suspect 2. First suspect 1 would become unhappy. So we cannot say this is deteriorating, or we cannot say it's improving. However, if you move -1, -1 to -10, -10, that's deterioration, definitely, because both people get worse off. If you move -10, -10 to -1, -1, that is improvement because both people get better. So here we have the Pareto dominant equilibrium. Once again, you have to mention not the payoff, the strategy. So confession is the Pareto dominant equilibrium of this prisoner's dilemma game. But the result is not Pareto optimal. Okay. This is the prisoner's dilemma example is shocking and interests many economists as well as social scientists. All scholars got interested. The reason is, okay, I'll change the order. The reason is like this. The 19th century, okay, we are in 21st, and many of you never experienced the 20th century, but I spent my youth in the 20th, okay? In the 20th century, for your information, there was World War I, World War II, of course, Korean War, which I haven't experienced, but that was 20th century. And before that, my great-grandfather's day, because my grandfather was born in 20th century. My great-grandfather, probably he was born in 19th, okay? 18 something years. In human history, the 19th century, so like 150 years ago, 200 years ago kind of thing from now, was known as a happy period. There's a scientist Newton, of course, he's not 19th century guy, but the Newton's physics seems to be explaining everything. So they make all of a sudden the locomotives, steam engine, and they make a ship, they can make a cannon and everything. And the human beings in those days felt invincible, especially the Europeans. So they often, without any hesitation, says, human can conquer the nature. Smart human can always find a way to solve the problem. Okay, that is the 19th century. But as you enter the 20th century, 19 something, I think 1905, one German scholar, Einstein, says the world is kind of relative. There's nothing absolute. And there's no way we can actually know something. Okay? What happened? In 19th century, people got so arrogant or so confident, they insist we build a ship named Titanic, and the ship is unsinkable. But then, the Titanic sunk 1912. So the so confident and people in the 19th century, they made so many things, and it seemed like people are invincible human beings. But then at the beginning of the 20th century, Some scholars says relativity, we can not be sure. 1912, the ship which is supposed not to be sunk, and then World War I in 1914. And millions of people die. And people ask, okay, human can conquer the nature? How come the Titanic sunk? And smart human can find the solution? How can you say human beings are smart enough when they are killing each other and millions die? And in 1940, there's another World War II, more people die, and people kind of lost hope. So 20th century, especially the early 20th century, 100 years ago, the whole world got so shocked. So this is year 2020. If you go back by time machine 1920, people would be appalled like, oh my God, just 10 years ago, we think humans are smart, we can conquer the world. And now the Titanic sunk and World War II, World War One, etc., etc., the economic collapses, the Great Depression in 1929. So all the half of 20th century, people got kind of shocked. We are not invincible. The science we trust so dearly after Newton cannot solve all the problems. And it's not only human being. Look at the prisoner's dilemma. I mean, human beings, they can get to -10, or let's go back to this. This, we can explain the traditional missile and nuclear missile, like Russia and America. They can have traditional missile or nuclear missile. Nuclear missile is much more dangerous. So if Russia and America are smart enough, they would restrain themselves to the usual missiles. But then, what did they do? Not only Russia, China, America, all of them got the nuclear missile. Okay? So, can you say they are smart? They are using nuclear missiles, killing each other, but then at the same time they are killing themselves. So, this Prisoner dilemma shows, and here what's interesting is Tom and Bill, they're not stupid. They are extremely smart, reasonable person, but then when they fight, they bring in the guns, risking their lives. So the thing is, even the smart people can make a wrong and terrible choice. That's why people got so shocked by this prisoner's dilemma model. Look at this. Medical insurance, that is an example. Let's say X-ray has a value of 10, while MRI has a value of 20. X-ray is a traditional 100-year-old technique. They look at your body, and when the bone is broken, what's inside it and things like that. But then it's not 100% correct. It's like black and white picture, something like that. On the other hand, MRI is like three-dimensional thing. If you use MRI, there's a high probability. Like if you have a cancer cell in your body, X-ray has a big chance of missing that. But MRI would probably got it very high accuracy. So people would prefer the MRI. They're willing to pay $20 for MRI, but X-ray for $10 because X-ray is not as effective as MRI. X-ray has a cost of 1. It's very cheap. On the other hand, MRI is a very complicated machine. It needs a lot of electricity, needs a room, a lot of people. So the cost is 15. So if you have a trouble going to the hospital, are you going to take X-ray or MRI? If these numbers are correct, I made up numbers, but if you take X-ray, your utility, your value is 10, but cost is 1. So your net value, your profit would be 9. If you use MRI, it's actually 20, but the cost is 15. So your net value is 5. It's 9 for X-ray, 5 for MRI. So even though you know MRI is better, you would choose X-ray. Okay? It's like, Professor Han, what kind of car are you taking? I'm driving 19-year-old SM5. Wow. So does that mean Professor Han prefers SM5, 20-year-old SM5 more than brand new BMW or Benz, Mercedes-Benz? No. I prefer brand new Mercedes-Benz much more than 20-year-old SM5, but SM5 is very cheap and Mercedes-Benz so expensive, like this X-ray and MRI. So people not only look at the value, but also the cost. In that sense, X-ray is a better choice for human being, for this patient than MRI. Okay, now Tom and Bill are potential patient, and they have a medical insurance. What is medical insurance? Basically, medical insurance is you go to hospital and the doctor charges you $10, but you just end up paying $2. Why? The $8 would be paid by medical insurance fund. But then, where this grateful medical insurance fund came from? From your pocket. You pay the money for that. So basic idea is, if Tom and Bill, only 2 person has a medical insurance, if Bill go to the hospital and charged $100, basically Bill pays $50 and Tom pays $50. Why Tom? I mean, Tom didn't go to the medical service, but then the medical insurance promise is that whenever medical cost happens, let's divide it by N, in this case 2. So 100, then half and half, 50-50. When Tom go to the hospital and charged $60, Tom pays 30, Bill pays 30. So that is medical insurance system. Okay, what if both people get X-ray? Tom will get $10 value because I assume that. Bill got $10 value in the previous here, 10. But then the cost is 1. So Tom pays 0.5 for him and 0.5 would be paid by Bill even though it's Tom's medical check. But Bill has check too. So Bill has a cost of 1. Bill pays 0.5. Tom pays 0.5. As a result, Tom pays 1. Bill pays 1. His profit value from X-ray is 10. Bill 10. That's why 10 minus 1, 9. 10 minus 1 equal 9. That is why payoff would be 9 and 9. What about MRI? The MRI cost is 15. So when Bill used MRI, he pays 7.5. Tom pays 7.5 for Bill. Likewise, Tom. But then both use that 7.5, 7.5. Bill pays 15 for the medical cost. Tom pays 15 for the medical cost. And the MRI, the value is 20, we assume. So 20 minus 15 is 5 and 5. Okay? What if Tom uses MRI and Bill uses X-ray? For Bill's use, Bill pays 0.5, Tom pays 0.5. For Tom's use, Tom pays 7.5, Bill pays 7.5. So when Tom uses MRI, Bill uses X-ray, both together, Tom pays $8, Bill pays $8. But then the X-ray's value is 10 for Bill, and he pays $8. He ended up getting a net profit of 2. Do you follow? If you just rewind and listen to what I just said, you would understand. It's not something complicated. It's very simple arithmetic. On the other hand, Tom choose MRI. So MRI gives him $20 value, but he pays 8, 0.5 for bills and 7.5 for himself. So So his net value is 20 minus 8, that is 12. Likewise here. So are they going to take X-ray or MRI? If Bill takes X-ray, Tom X-ray case, Tom gets 9, MRI 12. So when Bill takes X-ray, MRI is better choice for Tom. When Bill choose MRI, if Tom choose X-ray, it's 2. Tom choose MRI 5. 5 is bigger than 2. That is why MRI is a dominant strategy for Tom. X-ray is dominated by MRI. Okay? So the dominant equilibrium in this game is MRI, MRI. Both Tom and Bill choose MRI. And they end up getting 5 and 5. I mean, without medical insurance, they would have gotten 9 and 9. Now with this medical insurance, they end up getting 9 and 9. Why? Thinking about cost, X-ray is better, 10 minus 1. MRI is not better, 20 minus 5. But because they are sharing the cost, all of a sudden MRI become the dominant strategy. So we ended up not Pareto optimal situation. We call it overuse of medical fund. Okay? We are going to talk a little bit more about that in the next lecture. Thank you.